Okay, so we'll go over one example on how to use the functions in our help page. So we have this question. So they collected data from 25 randomly selected transactions and found the purchase amounts. The mean is 2371 and the standard deviation is 1341. The analyst wants to know if the mean purchase amount of all transactions is at least $17. So first of all, what is the null hypothesis in this question?
Since we're talking about means, it's going to be mu
Awesome.
equals 25? No. 17.
17. So, yeah, perfect. So, since we're talking about the mean and not the population, right, we want to look at the mean. So, it'll be mu equals 17. And our alternative hypothesis would be mu is,
Less than 17.
well, it wants to know if the mean purchase is at least $17. So greater than 17. So that would be our null and alternative hypothesis. And so our question, first of all, okay. So because it's the alternative hypothesis is greater than 17, would this be a one-sided or two-sided? One-sided, awesome. And it would be two-sided if it's not equal to 17. And then, so now we're going to look at finding the test statistic and p-value. So, okay. So, hold on just a second. Okay. So in our help pages, if we look, it shows you how to find the standard error, which is the standard deviation divided by the square root of the sample size. And we can also find the test statistic by using this function right here. And so we'll do that first. We'll find the test statistic with that function. So first we're going to do the mean. And in this question, what was the mean? It was 2371. So we're going to put that in there. Then we're just going to find the standard error. And that is the standard deviation divided by the square root of n, right? So what is the standard deviation? It's 13.41 divided by the square root of, and it was 25. So we got that. Then we're going to find the test statistic by using this function. So we do the mean minus our mu, right? Our alternative or null hypothesis value, which is 17, divided by the standard error. So that's our TS function. And to see that, we can run it. And we can see that the test statistic in this question is 2.501. Okay. And then we use that value to find the p-value of this hypothesis test. Okay. So in our help files, we can see that the p-value function is this one, but this is only for a two-sided test. We do multiply, we multiply by 2 if it's only a two-sided test. If it's not a two-sided test, we don't need that 2 times. So we're going to use that function to find p-value. Okay, so our p-value function is pt. The the absolute value of the test statistic, comma, and since it's not a two-sided, we're going to do that. And then degrees of freedom. So how do we find degrees of freedom?
It's just 1 minus your population.
Right. So it's just 1 minus n, which is 25 minus 1, which is 24. And so we're going to run that. And so p-value is this number right here. This number. Okay, so is this a small p-value?
Yeah.
Yes, because most of the time our alpha value is 0.05 or like 0.1 or something like that, and we can clearly see that it's lower than our alpha value, which means that we have enough evidence to reject the null hypothesis, and so we can conclude that the mean purchase amount of all transactions is going to be at least 17 in this question. And let's see what else covers. So yeah. What did they say alpha value is? Okay, so in this question though, the alpha value that they wanted was 0.005, right? And so if we had an alpha value of 0.005 though, would we be able to reject? No, because the p-value is greater than the alpha value, right? And so since this is a particularly small alpha value that they wanted, we failed to reject because the p-value is greater than alpha. And so we can't conclude, there isn't enough evidence to conclude that the mean purchase amount will be greater than 17. So yeah. Any questions? Awesome. Alrighty.